we're continuing with section 3.10, and this is related rates. This time, example number 6, Joe, who's 6 feet tall, is walking away from a 14 feet tall lamppost at a constant rate of 3 feet per second. When Joe is 10 feet from the lamppost, how fast is the length of Joe's shadow changing? How fast is the tip of the shadow moving away from the lamppost? Let's remember this. Rays of light are straight lines, and light kind of emits straight lines, or we can imagine that the rays of light above somebody's head is going to go in a straight line. And so when let's say Joe's standing over there, the light from the lamppost, here's the 15 feet tall lamppost, the light from the lamppost goes above his head and then down here, but it doesn't go through him, so the shadow is built over here basically. And so we want to, the other interesting part is that we know that this shadow basically gets bigger and bigger as Joe moves away from the lamppost. And so also the distance, when Joe moves away from the lamppost, the distance of Joe and the lamppost increases. So that's the beginning part of this, like introduction part of this question, that we saw that the shadow is getting bigger and bigger as he's moving away, and the distance is increasing. So let's call the length of the shadow S, and then the length of the distance from Joe to the lamppost, D. How are these related? Like lamppost is kind of a straight up lamppost, so it's making a 90-degree angle with the ground. So is Joe, and so basically you can see two triangles in here. One is this one, and then the other is this one. And because Joe and lamppost are both perpendicular to the ground, they're parallel to each other. According to what we learned in geometry, when you have another triangle, and there are two triangles that are sitting like this, and here they're sharing this angle, and they are both have a right angle. That means that all three angles of the two triangles are congruent, and therefore the two triangles are similar triangles. And so we have to use the fact that they're similar triangles to figure out how the S and then 14 and 6 and D are related together. So let's write down use the similarity to write down a relationship between S, D, 6 feet and 14 feet. In here, S, the ratio of S over 6 feet is the same as this side to 14 feet. What is this side? This side is S plus D. So I'm writing S over 6 is equal to S plus D over 14. And then I can simplify this a little bit, and I can write this as let's multiply both sides by 14, and then I get 7S over 3 is equal to S plus D. Right? I can also multiply by 3 and get 7s is equal to 3s plus 3d. Now, from here I get 4s is equal to 3d, or s over d is equal to 3/4. Now I can use this equation that connects, again, we discussed that s and d are both changing, and now I connected the two quantities together. Let's see which one I know at the instant and which one I don't know at the instant. As I'm reading, it says he's walking away from the lamppost at the constant rate of 3 feet. That means d is increasing at 3 feet. So I know that d over dt is equal to 3 feet per second. And now, now that I have this equation, I can take the implicit differentiation of this equation and get 4 is the constant, derivative of s with respect to t is equal to 3 is the constant, derivative of d with respect to t. I know this one is equal to 3, and then I can calculate ds over dt, and ds over dt is going to be 9 over 4, or 2.25 feet per second. So I answered the first part of the question. Now let's come back and answer the second part of the question. So in the first part of the question, we figured out that ds over dt, we calculated that ds over dt is 2.25 feet per second. And now, to find this distance is actually, we're trying to take the derivative of d plus s. According to the laws of the derivative, this is equal to dt plus ds dt, which is now if I figured out one of them, which is 2.25. This one is 2.25, and this one is this one was given, that was 3, so I can add them all up to get 5.25. And this makes sense. We're saying that and s is increasing at this rate, d is increasing at this rate. What is the rate of the increase of the two of them added together, which